Imagine being given instructions on how to complete a task. Now imagine these instructions are committed to stone. They don't change, ever. And now imagine that somebody tells you, out of the blue, that they don't want you to follow the standard operating procedures that you've been programmed to follow. They tell you that your instructions are now wrong, and you need to learn something completely new. Your code is now invalid. It is now wrong, and it needs to be patched. This is the basics for rebanding, but it gets much worse than this. My name is Phil Lichtenberger, and I have been in the scanner radio hobby for over 4 decades, and I'm going to take part of my knowledge and transfer that over to you in this series that we call Scanner Radio University, which is meant to help you out with the scanner radio hobby. But before we talk about rebanding, we have to give you the lay of the land. Now, first of all, this is a problem specifically to the United States. To make sure we're on the same page here, let's just start from the beginning. The RF spectrum is broken down into frequencies, and those blocks of frequencies, there are smaller blocks. And these blocks are there to help people manage where the different frequencies are going to be assigned to the end user. So, for example, what we're talking about today, in the 800 band, we see a lot of different kinds of users. We have public safety. We have businesses, we have cellular phones, and we have what is called SMR and ESMR services. And one of those services was Nextel. Nextel started out as a push-to-talk radio service, and they were huge in the mid to late 1990s and even into the early 2000s. And eventually, Nextel was gobbled up by Sprint, and then Sprint was eventually purchased by T-Mobile. But no matter who ended up owning them, the damage was done a long time ago, and we are still basically paying for that today. So as we said, Nextel started off as just a push-to-talk company. They were an enhanced two-way radio communications type of solution for small businesses, and primarily businesses that did not want to set up their own radio systems or that did not want to lease radios from a bigger radio company. You see, with Nextel, you could basically go into any Nextel store, a Radio Shack, or anything like that and buy a Nextel push-to-talk radio, get services, and your small business was now able to communicate directly push-to-talk as if they had a walkie-talkie in their pocket. Eventually, Nextel added cellular telephones on top of that PTT network. And now this was great because it gave the end user not only the ability to have immediate access to their fleet, their coworkers, to dispatch, or anybody else that was on their push-to-talk network, but also a way to communicate with landline and other cellular phones. Now, the problem developed because of where Nextel was on this RF spectrum or in the RF blocks, this RF landscape. You see, they were kind of sandwiched in between public safety and other radio users. And it's this positioning that caused problems with public safety networks. The original layout from 851 to 854, we had a general category of users. And from 854 to 861, we had interleaved spectrum, which is basically a general category and a spectrum made up of public safety, businesses, SMRs, and ESMR. From 861 to 866 is where you would find Nextel, and from 866 to 869 is where you would find public safety. Nextel was positioned so that it was interleaved in with public safety and also below the dedicated public safety spectrum band. Now, as we've established, Nextel was not a push-to-talk network anymore. It was a cellular company now with push-to-talk abilities. Nextel now needed to be rehomed closer to their cellular brothers and sisters and cousins and uncles and everybody else. Think AT&T, Verizon, Singular, Metro One, etc., right? And the spectrum that those carriers were assigned to. And why did they have to move? Why did they have to rehome? Why do we have to have rebanding? Well, this was a problem with public safety networks and trunk radio systems. As we've talked about on other scanner radio videos and podcasts in this series, we know that most public safety systems are built up high, use a lot of power. They're made for coverage, right? They're on mountaintops, towers, tall buildings in urban areas. This is where they can get the largest footprint for all their users, the mobile radio users, their dispatching centers, their portable operators, right? Well, Nextel, on the other hand, they were built for capacity. and they had a lot of users, so they were positioned closer together and closer in. They were on rooftops and built very densely, right? Of course, they did have some tower sites too, but again, their locations were packed in much closer than what a traditional two-way radio system required. Now, this would be a problem with public safety because of how close these frequencies were in relation to each other, and the fact that Nextel sites were closer to the ground, were denser, and a lot of times when public safety radios or users would pass too closely to a Nextel site, it would cause their radios to begin to overload. It would raise that noise floor up. And when that happens, it would mute the radio, they would lose service, and this would start to become a huge public safety issue. And eventually what would end up happening is that they would decide, with a lot of coordination, to swap frequency spectrum with public safety. And by doing this, public safety would move down and Nextel would move up closer to the cellular carriers. So basically, public safety would go from 866 to 869 down to 851 to 854. And they would have exclusive rights in that range of 851 to 854. Business users would share 854 to 862, and Nextel would move from 851 to 854 all the way up to 862 to 869. And this move was great because it created an expansion band for public safety and also a guard band between Nextel and the other users in the spectrum. So now we've got this network that was never supposed to change. It was always supposed to be where it was configured to be at. It was basically committed to code. And now all of a sudden, instead of the users being part of this part of the spectrum, they were now over here on this part of the spectrum. And this is why we had a problem with rebanding when it first came out. You see, many scanner radios became obsolete overnight as soon as radio admins rebanded that trunked radio service. These scanner radios could no longer be used on these rebanded systems. And before we explain it in detail as to why this is a problem with many scanner radios and which systems specifically these were a problem with, I want to take a second here to thank all of my Patreon supporters. It's my supporters that have helped keep this podcast going, even during my hiatus when I was battling cancer. And Patreon supporters have allowed me to continue to keep the podcast published, allowed me to keep the podcast available, and have allowed me to be able to purchase the equipment to bring the podcast back. By supporting the podcast on Patreon, certain tiers will get access to the podcast early, and also we have monthly Patreon meetups. If you'd like to join us on Patreon, you can do so by going over to scannerschool.com/Patreon. Again, I want to thank all of my continued Patreon supporters. And if you could do me one more additional favor here, please subscribe to us over here on YouTube if you haven't yet subscribed to us. That really will help our numbers and help us grow. So again, why was rebanding a problem for many scanner radios? Well, you see, the Motorola protocol basically hard-coded the mapping or the layout of their systems based off of a mathematical equation. Your radio, your scanner would know exactly where each channel belonged to. It knew what frequency to go to, and this was set in a standard. And by rebanding and remapping the existing frequencies with new frequencies, these channel numbers now were changed. They were remapped. They were rebanded. Now, the good news here is that if we had a system that used LCN, and we've talked about those on previous Scanner Radio University podcast episodes, like EDAX and LTR, well, they were really immune to these changes in our scanner radios because we had to tell the scanner that channel 1 was this frequency, channel 2 was this one, channel 5 was this one, right? We were telling the scanner where everything was right out of the box. So those scanners that needed LCN, or those systems rather that needed LCN, they would work very easily with rebanded systems. But when it came to the Motorola protocol, this is where we began to have a problem because radios monitoring these systems couldn't do rebanding. And that's because Motorola had predefined its band plan as the protocol. It already had a channel map. It knew based off the frequency and the step sizes and the upper and lower channel numbers where everything else would have to be aligned to. But when you take, let's just say channel 440, and you move it from point A to point B, we now need to override the code to tell the scanner radio that 440 is now in position B instead of position A. It has a new home, a new address, a new frequency. Certain scanner radios allowed for firmware upgrades, but they were still new to the market at the time that a lot of these rebandings were happening. So newer radios by Uniden, by GRE, and then as a byproduct by Radio Shack allowed us to reflash the firmware in our radios, add a new trunking protocol for rebanding, and then add the new rebanding mapping to the scanner radio. Now, you also needed to figure out what this mapping was supposed to be. But if you had computer software such as Butel's ARC series of programming or ProScan, you could just simply push a button and load in that rebanding channel mapping. It would work just like magic. And to this day, this is why when you look at a Motorola Type 2 system in radio reference, you may see a big banner that says this system has been rebanded. And of course, we need to know this so that we load in the rebanding profile when we program in Motorola Type 2 systems. And eventually, this is a problem that's kind of sorting itself out with us in the scanner radio hobby, because as these Motorola systems and as these EDAC systems and as these LTR systems are going the way of the dodo, as they are sunsetting, they are getting old, they're becoming legacy products, newer systems are coming online to replace these older systems like P25, NXDN, and DMR. And a lot of these already have information built into the protocol to overcome these kinds of issues if they should ever arise again. But if you were in the scanner radio hobby about 20 years ago when rebanding was just being pushed down our throats, well, it was mass hysteria. It was crazy. It was confusing. And I loved it because it gave me the time to actually sit down and understand in greater detail how these systems worked and how to figure these out, how to figure out the step sizes and the frequencies and map these out and see if my scanner would work based off of the calculations that I was making. But if you were an end user that just wanted your scanner radios to work, this was a thing of nightmares. But again, at this point, it's old news. We did it. We made it. And scanner radios evolved because the technology evolved because of it. And of course, this is completely different from splinter systems on Motorola networks, which we'll probably talk about on another episode of the Scanner Radio University. But again, if you like this type of podcast episode and you found it helpful, make sure you let me know in the comments, and make sure you subscribe to us here on YouTube or in your favorite podcast player platform. We are still deep into the Scanner Radio University series, and we have plenty of more videos like this to help you begin your journey in the scanner radio hobby. So again, if you found this helpful, give me the thumbs up, subscribe, and we'll catch you next week on another Scanner Radio University series right here on Scanner School, where we'll teach you everything to know about the scanner radio hobby.